Good morning. We're going to get started. I apologize for the delay. Again, security is a little tough here. On behalf of the Association of Ecosystem Research Centers and the American Institute of Biological Sciences, we're delighted to be here once again for a congressional briefing. AERC is a consortium of research centers, institutes, universities, federal agencies, with the mission of understanding ecosystem sciences and bringing the best ecosystem science we can to bear for management and policy. Each year, we hold a congressional briefing that not only talks about sort of what the state of ecosystem sciences is, but the topic we choose is the one that we think is really relevant to current policy issues associated with our fragile ecosystems. This year is no different. We've put together a great panel that are going to talk about a process called horizon scanning, in which you catalog potential threats, filter information, prioritize information, and think about risk. Think about the areas where we're most at risk of the known and predicted risks, but also risks that we might not know. My name is Todd Kraut from Florida International University, and I'll be the host. This year's speakers include Dr. Jonathan Colby, who's a research scientist at the Smithsonian's National Zoo and Conservation Biology Institute. He'll be giving us a broad overview of what horizon scanning is and how it works. Next, we'll have Dr. David Bengston, environmental futurist, Strategic Foresight Group, USDA Forest Service. He'll talk about how they are applying horizon scanning to our national forests. And then finally, we have Dr. Lucinda Johnson, who's the Director of Research, the Natural Resources Research Institute at the University of Minnesota, and she'll be talking about how they apply horizon scanning for the Great Lakes management. So without further ado, I will turn it over to Jonathan Colby. Oh, there you go.
All right, thank you very much. And thanks for everyone for being here today in person and virtually. My name is Jonathan Colby, and I'm going to start the presentations by just trying to familiarize all of you a little bit more with horizon scanning. Some of you may or may not have heard that word before. I've been hearing it more and more frequently, but just to get you more familiar with what it is, what it entails, and how it can apply to the work that we all do. So basically, from a broad perspective, what is horizon scanning? It's a systematic approach to detect early signs of developments, opportunities, and threats. And it follows a transparent process encompassing the best available diversity of information and experts in those subject matters. And it provides a way to prioritize resources. And that's kind of the real big take-home message is how do we work with limited resources, especially towards the development of early warning systems. So horizon scans themselves are not, entirely a early warning system, but they very much contribute towards the development of effective systems for the future. And in the work that we all do and you do in the audience today, I think it's really important to think about horizon scanning as a tool towards anticipating upcoming struggles or challenges that may affect your constituents. And in order to get ahead of the curve and to anticipate and envision what these new problems might be, so that we can better develop cost-efficient and time-efficient solutions to these problems before they emerge and become much bigger issues. And I think taking a step backwards and thinking about that more deeply, it's likely that all of us here today have done some component of a horizon scan, formally or informally, without really putting a name to it. So I think part of my goal and our goal today is to kind of put a name to the process, have you think about it a bit more strategically so it can help you find the information, find the people to be involved, and be more likely to reach the policy goals that you may have. Figuratively and literally, horizon scanning is looking towards the horizon. And I think an important distinction to make is that horizon scanning, and I'll talk a little bit more about the process in just a bit, but it's not simply an academic exercise in literature review, or looking at obvious, well-researched information. You're looking at the horizon, and in a period of time where a lot of information might not yet be available or obvious. So you're looking for early signs and symptoms of things to come. And it's not always bad things. I mean, that is largely what we kind of focus on, is how do we mitigate and prevent negative consequences. But it can also look for positive signs of things that could be beneficial too, just to keep in mind. And there's a couple of reasons why we might want to engage in a horizon scan. Two of those common motivations is, firstly, a negative event. So something bad might have happened that kind of brought to the forefront a bigger issue that not only deserves attention at this moment and why it happened, but how can we prevent them from happening again? How do we better understand other similar or different threats? So, one example that I'll talk about a bit more later, the emergence of COVID-19 is what led to the work in horizon scanning that I'm doing. But also, alternatively, it might just be part of an organizational strategic process of planning for the future. These are sometimes one-off, horizon scans, but ideally, horizon scans are iterative and continue. Once one leads off, another one may begin. And that's where a lot of power from horizon scanning comes up, is anticipating the future better. So I'm just going to briefly go over the process just to give you more of a visualization through the rest of the talks today. Like what is horizon scanning per se, just to get that out of the way. And then we can talk more about how it's applied and what it can do for us. So there is no one single specific process that everyone does, for horizon scanning, but generally it follows about 5 or 6 different stages. That starts with scoping. Scoping is almost before the process starts, where you're thinking about what are the boundaries of your topic in both time and geography and stakeholders. What are the boundaries that you're going to set for yourselves to do a horizon scan, to make sure that you are broad enough that you're encompassing enough information that you're getting those weak signals, but not so broad that you're overwhelming yourselves with so much information that it's hard to then go through it. In the later processes, when we start scanning and filtering and prioritizing. And these are all just stages where over and over, we go through all these different, suggested topics that come up through brainstorming and different stakeholder work groups to say, okay, well, from this very big body of information, how do we filter and prioritize and rank those different issues and concerns to a very short list of new and emerging things that we should be focusing and investing our time and resources on. And then disseminating. And often dissemination comes in the form of reports, but also visual graphs of risk matrices, and then also in the form of databases, which could be ongoing databases, for example, where, at the end of the horizon scan, it might have set up an infrastructure for continual feedback and adjustment. Now I'm just going to give you a few examples of how it has been applied or has been thought to be inserted in a positive way to some different issues. And this was an interesting example in terms of pollinators. And again, just to emphasize that the real point and purpose of horizon scanning is to look beyond the present and the past, right? And to look for signs of things that are yet to come, because that's when we can have the most cost-efficient and time-efficient policy responses to emerging issues. So for example, this is the end result where, a very large number of issues that were brought to the table by a bunch of experts was then pared down to this one simple figure. And you'll see that some of the main topics and headings, around this circle, around the B, are not completely new and different topics, but it's the nuance of the issues within those that are. So for example, in pesticides, a lot of us have heard about the neonicotinoids and the negative effects of those, but we haven't heard about some of the other ones like the sulfoxamine pesticides or the increasing use and unintended consequences of fungicides on bees. So it's those nuances of things that, well, actually, maybe these are different directions that we need to also prioritize at the present, even though we're so busy looking at what has happened in the past and how much of a challenge it is to fix those issues. Another somewhat different but interesting application was in this perspective piece about how an autonomous integration of horizon scanning with biosurveillance could potentially be used to detect very early signals and signs of bioterrorism and biological warfare. And how would that look like? How would we detect those signs as rapidly and quickly and efficiently as possible to respond to something like that? That would be easy to miss if we're just looking at the present. And thirdly, in the work that I'm doing right now, I'm looking at wildlife trade and the spread of diseases in a One Health perspective. And One Health is the interconnectedness between environmental health, human health, and animal health. And I used to work for the U.S. Fish and Wildlife Service as a law enforcement officer, regulating the import and export of wildlife into and out of the United States. And millions of animals are traded globally each year. And the United States is one of the major consumers of those animals. But interestingly, while we're so busy doing that law enforcement work, what a lot of people misperceive about that role is the disease aspect. So a lot of people look at, what are we doing now? What have we done in the past? Well, CDC regulates diseases for human concern. USDA regulates diseases for agricultural concern. But then you get to wildlife and the emerging recognition that you have these zoonotic diseases that affect humans and animals. And a lot of the laws and policies we have today were created a long time ago, before this was really a known and acknowledged threat. And as we all have known and experienced from COVID, this is a thing that has happened time and time again. And in response to COVID, there have been directives that went down through the Department of Interior that filtered down to Fish and Wildlife to start looking forward a bit more and looking at different ways of implementing the Lacey Act and listing species as injurious. And what that means is essentially what species should be banned from import because they may pose such a threat to human or animal health. And that was the origin of the work that I'm doing now with the Smithsonian called One Health Protect. And this is just a really simplified, abbreviated framework of the integrated global horizon scan and risk analysis that we're doing, just to kind of represent to you like the thought process of going into these processes and what comes out of them. So, we've had many previous zoonotic outbreaks before. We've had SARS, we've had MERS, we've had monkeypox before. But now, because of COVID-19, it really kind of sprung forward that actually we need to look ahead. We need to look at this differently and take some different policy actions, which then, sparked part of this directive from the American Rescue Plan Act, which provided funding and support for the project we're doing called One Health Protect. And in this project, we're doing an integrated horizon scan and risk analysis. So something I didn't mention before was that often horizon scan will entail a risk analysis, or a risk analysis might be done alongside it, but they kind of feed back into one another. And in the work that we're doing, we're kind of thrust into this already because COVID-19 has been recognized as such importance. Traditionally, we might have done a horizon scan to come to that recognition. What are the threats to human health? What are the threats to emerging from the wildlife trade? But we've kind of already been put into that cycle. But we still need to question the system and think, well, what factors are contributing towards the emergence of diseases in humans from the wildlife trade? What pathogens have come into the United States before from the wildlife trade, and why? And not just look at that they have, but question the why, to look ahead and think about, well, what can we do to insert ourselves in policy to better prevent these things from happening? And that's what spills into a risk analysis. So that's where it gets a lot more specific. So in order to answer these, what may seem like simple questions, like what are the threats to human health from wildlife trade, we need to know, well, exactly which species are coming into the country. And there are thousands and thousands of species, many of which that have never been evaluated for disease threat before. And then what is it about those species that make them more or less likely to affect human health? And where can we insert ourselves in a policy aspect to mitigate that risk? With the end-all goal being fewer deadly zoonotic outbreaks introduced into the United States from the wildlife trade. And so from our perspective, there are a lot of different kinds of policy and management benefits from this kind of thought process and this kind of scientific evaluation. And that could be research to fill data gaps. And not only to answer these questions, but also to be the beginning of new horizon scans. So there are many, many unknowns in these kinds of landscapes. And often that is what calls for continued work, continued policy investigation and scientific review is, well, here's what we've been able to bring to the table, but here are all the new things we've learned that we don't know, that we need to know. More specifically and tangibly, this kind of work will potentially lead to new injurious species listings. As I mentioned previously, under the Lacey Act, this will create the science that then goes back to the U.S. Fish and Wildlife Service for their decision on how to respond to that threat. And the one specific avenue that's being explored is injurious species listings to help control the wildlife trade, to reduce the threat to people. And that also kind of spills into developing refined permit systems. So maybe this will call for a refinement in the way permits are issued or sanitary certificates or veterinary certificates to certify that the trade that does continue, may be done in a more sustainable and safe and healthy way, which also then spills into targeted outreach and education. So it makes you think about who are the stakeholders that we might not have envisioned before, who are being affected by these issues that need to be informed and better prepared to reduce their risk. And again, with the overarching goal of having less frequent pandemics from the wildlife trade and or less severe pandemics when and if they do happen. And so by the end of today, I think it would just be really good for all of us to think a little bit more deeply about how horizon scanning may apply to the work and the policy goals that we all have. And to me personally, I feel that, as a scientist working in horizon scanning and policy, that horizon scanning is more than just a process. To me, it's also a thought, a way of thinking about the future, because as a society, we often have so much on our plate with so much limited resources that we're always thinking about the present and the past because it is so overwhelming. But the real benefit from this process is saving time and cost and effort in the future by having that foresight of looking ahead. And that's what you'll hear a little more about in the next two presentations. So thanks for attending, and we'd love your questions at the end of all the speakers.
Thank you very much, Jonathan. As a reminder for those of you attending virtually, please use the chat and type in your questions. After all three speakers are finished, we'll put them up front as a panel, and I'll read the questions that you guys submit. So next we have David Bengstead, who's going to talk about how we're using this framework that Jonathan just talked about for our national forests.
Right, thank you. Thank you, Todd. Good morning, everybody. Jonathan did a very nice job introducing horizon scanning. I'm going to talk about how we've approached it in the strategic foresight group that I work in the Forest Service. Then I want to give you two examples of emerging issues that we've seen in our horizon scanning work. Out of thousands of signals of change in our database, there are lots of issues, trends, new developments that emerge, and I'm going to talk about just two of those. And then a tool, thirdly, I'll talk about a tool that we use to explore the implications of those emerging issues. It's not enough to just identify them, we have to understand what they mean, and then some concluding thoughts about the value of this work in what we do in the Forest Service. So here's the way traditionally we've scanned the horizon, literally in a fire lookout tower. But in our work, horizon scanning is defined as a process for finding and interpreting the meaning of early signals of change, mostly in the external environment of our organization and our field. And we focus on the external environment because if you're a professional in whatever field you're in, you have a pretty good feel for what the new developments are within your field, because you go to conferences, you read journals, you interact with your colleagues, but it's developments in completely other fields sometimes that can blindside you if you're not thinking about them, preparing for them in advance. And so horizon scanning is widely practiced in the private sector all over the world. It's practiced in every branch of the US military and in intelligence agencies. In our group, we've had interaction in the past couple of years with folks in a strategic foresight unit at the US Secret Service. They do some horizon scanning there. And there's a growing number of not just the Forest Service, but other federal agencies that are doing various types of horizon scanning. I participated in a OPM horizon scanning exercise that was focused on the future of work several years ago. Our Forest Futures Horizon Scanning Project, in setting it up, we partnered with some folks in the Foresight graduate program at the University of Houston. We recruited a diverse team of volunteer scanners. Diversity is really a key because people from diversity of all different types of diversity have different perspectives on whatever the issue is. When those scanners find an interesting signal of change, they post it in an online database that we have. Currently it's about 3,500 signals of change in our database of individual scan hits. And then we look through that database and explore the implications of what seem to be the really most important issues that are emerging. We consider all types of signals of change, the weak signals, the trends and counter trends, because every trend has a counter trend, at least in the social and economic realm. We look at the broader drivers of change and the wild cards, the low probability, high impact events that unfold rapidly and can really be highly disruptive. Might be disruptive in a positive way or in a negative way, but certainly the pandemic has been an example of a type of wild card that we've had to deal with. If you're interested in more detail about this, let me know and I'll send you some. We have many publications that talk about our horizon scanning efforts. So 2 quick examples of emerging issues that I think have a lot of significance for forestry and the forest sector and all the stakeholders involved in forestry. The first is an emerging social, cultural, and political issue of growing Indigenous empowerment. This is something that one of my colleagues, Mike Dockery, he's a citizen Potawatomi tribal member. He spotted this early on and started posting signals in our database. And that got the rest of the scanning team thinking about this, looking for those types of signals. And so we have quite a few of them in our database. Mike wrote a really nice short article on Indigenous empowerment as a driver of change in forestry and natural resources. And this is part of his definition of Indigenous empowerment. It's very broad ranging. It can affect so many things. Lots of dimensions to it. So here are, I'm going to give you 3 individual scan hits that illustrate the different aspects, the different dimensions of Indigenous empowerment. One is the return of reacquisition of tribal land. So there's a tribe in Virginia in this particular article that reacquired some sacred land, their ancestral homeland. It only took 400 years, but we have a lot of that reacquisition of land happening all over the world. Or as in this case, regaining the management authority over management control over forest land. Tribe in Oregon that had some restrictions on the way they could manage their own forests. Another dimension of Indigenous empowerment is the really significant impact that Indigenous knowledge or traditional ecological knowledge is having on sustainability science. And it's quite significant. I was at a conference last week and one of the keynote speakers focused on this issue and there was a lot of discussion about it. So there are indigenous science degree programs popping up at a number of universities, and it's having more and more of an impact. We also pay attention to the counter trend of indigenous disempowerment or anti-indigeneity, as this there's a series of articles in High Country News about this, how around the world there are anti-indigenous organizations and sympathizers working to undermine the collective rights of indigenous peoples. The second emerging issue, so indigenous empowerment, it was a social trend. This is a technological innovation, and it's one that's farther out. Lab-grown wood. You're familiar with lab-grown meat, which 8 years ago sounded completely crazy, especially because a single hamburger patty of lab-grown meat cost $280,000 to produce. And now it's being served in restaurants, and there are a number of large companies gearing up to produce this on a large scale. So in just 8 years, it went from that's crazy to it's a commercial product now. And there's some researchers at MIT who've been developing this. About 1.5 years ago, they first started publishing about it. And it's really a very simple process to produce lab-grown wood. So the scientists, and I talked to one of them, they believe that it's a process that can be scaled up fairly easily for commercial production. So if you could grow your own, not grow your own, but if you can grow a dining room set in an industrial facility, or grow a guitar, that has huge implications for forest products and for forest management and forest sustainability. Goodbye deforestation, I don't know, but it's important to explore the implications of this type of emerging technology. When we see an interesting issue like this is a short article that I wrote as soon as I ran across this scan hit. And we want to get it out to people within the field. And so this is a Society of American Foresters publication, and the article about lab-grown wood, which was the first time that they had heard about it. There are many, many more emerging issues that are coming out of our horizon scanning. We have a very broad approach to it. The only focus is that there has to be some tie, or some maybe a weak tie, to forestry and natural resources. And so here's some more issues. We're right in the middle of developing, one of our projects is to go through the last year of our database and identify the top 10 emerging issues that could affect forestry and the Forest Service in the future. And these are some of them. All of them have some link to the future of forestry and how it's practiced and the interests of our stakeholders. I wanted to talk a little bit about this tool that we use to explore the implications. It's called the implications wheel, or the futures wheel. And I like to think of it as the secret decoder ring that we use to uncover unanticipated consequences, possible future consequences of change. Joel Barker is a business futurist who developed this tool, and he calls it a strategic exploration tool for scouting the future. It's a highly structured process. It's not just free-form brainstorming. There are a set of rules that participants have to follow. And it can be done in person, like these folks gathered around a sheet of paper. We used to do that pre-pandemic. Or it can be done online with some software that we have that works really, both approaches work really well. Here's how it works. There's some change of interest. It might be a new policy, a technological innovation, a social trend, and that goes in the middle. And we ask the question, what might happen as a direct result of that change? And some direct impacts or first order impacts are identified. Just 4 shown here, but there might be 8 or 10 direct impacts for a complex change. Whoops, jumped ahead there. And then the question is again repeated for each of those direct impacts, what might happen as a direct result with no significant intervening events and second order impacts. And then it's repeated again for the third order. And by this time, this is a highly simplified figure. You might have 200 or 300 or more of these bubbles with direct and indirect impacts of the change. And then the participants score each of those for likelihood and desirability. And the really useful thing about this is that it teaches people cascade thinking, how one change can lead to another change, and that can lead to something else. And it uncovers some of those unanticipated consequences of change. Just a few concluding thoughts about the value of our horizon scanning system and how we've used it in the Forest Service. First of all, within the strategic foresight group that I work in, it's right at the center of many of our projects. So scenario planning, the future of fill in the blank, outdoor recreation, wood-based nanomaterials. We've done a number of the future of X type projects. We developed a foresight board game, which we use as when we're doing training sessions or foresight workshops to get participants thinking first right off the bat about the future in a different way. And all of the impact cards and the wild cards in our board game come directly from our horizon scanning database. Secondly, the goal in horizon scanning and all foresight work is developing foresight, and that is absolutely critical for forward-looking planning, management, and policy. And Teddy was one of those pioneers of the progressive era conservation movement. And then finally, Peter Schwartz is another business futurist, and his classic book, The Art of the Long View. In the work that we do, we are striving to spark ongoing strategic conversations about the future. And that is really a valuable thing. As Peter Schwartz says here, it's really maybe the most important thing is helping to develop that forward-looking culture within the Forest Service. There is my email if you can read it, and please contact me if you have further questions. I'll just put that there.
Thank you very much, David. There are a number of chats asking for links to some of the various Forest Service documents you referred to. So please provide those to the folks. If you send them to us, Yatsna can forward them out to all the registrants. So thanks very much. Okay, next we'll hear from Lucinda Johnson, who will talk about using this same framework for the Laurentian Great Lakes. Lucinda.
Thank you, folks. It's really nice to be able to talk about horizon scanning and its application in the development of an early warning system. All right. Okay, so the work I'm going to be talking about is the effort of a large team of individuals, including myself and another group, but mainly a work group that is embedded within the International Joint Commission. I'm going to talk about the Laurentian Great Lakes, why we need an early warning system, the role of the International Commission. Talk threats and stressors. So the Laurentian Great Lakes, for those of you that may not know about it, would be odd, sits in the middle of the continent between Canada and the US. It holds 21% of the world's fresh water, an incredibly important resource. And not only that, but it's home to 107 million people. And if we added up all of the economic activity within the basin, it would represent the third largest global GDP. So very significant economically and politically, frankly. So why do we need an early warning system? Here's some two particular examples, primarily focused on an ecological phenomenon and political local phenomenon. So in the early 1980s, a consultant for Environment Canada identified zebra mussels or Dreissenid mussels in the ballast water coming from the Baltic Sea. They stated that there was a potential for these to become established in the Great Lakes and in freshwaters around, outside of the Baltic. And had we been able to take action at that time, billions of dollars in infrastructure damage could have been prevented, but also irreparable damage has been done to the Great Lakes ecosystem as a result of this establishment of these species. In contrast, the Toledo water crisis, which took place in 2013, was the result of a harmful algal bloom that occurred right outside the water intake of the treatment plant for the city of Toledo in Lake Erie. Now, harmful algal blooms are not a rare occurrence, but it turned out that the community nearby Toledo had experienced such a bloom the year before, and had that become an early warning signal to the potential for the damage, which resulted in $65 million of lost revenue to the city. Such an early warning system could have helped Toledo anticipate that problem and plan for it in the future. So the Laurentian Great Lakes are this incredible boundary water resource, and there is a treaty that was signed in 1909 that helps the US and Canada, or describes how the lakes should be jointly managed. The water quality agreement is embedded in the treaty, and this is a very significant tool that the US and Canada use for managing the Great Lakes. The International Joint Commission, which is a binational entity, plays a very significant role in overseeing the progress towards the implementation of the water quality agreement. And embedded in the IJC is a water quality board, and it specifically is charged with identifying emerging ecosystem issues. And the Science Advisory Board of the IJC is tasked with providing advice and research to the Water Quality Board and the IJC. So over the past 5 years, we have been working on developing a framework for an early warning system, because currently the Water Quality Board operates on an ad hoc basis in terms of identifying threats and stressors. So we're interested in formalizing a process by which the Water Quality Board can anticipate and act on these stressors. So the goal of the Great Lakes Early Warning System is to use science to identify and prioritize potential threats and stressors, to develop a pragmatic mechanism that can be useful across a system that is incredibly complex and dynamic. Some examples of some of the stressors that would be considered include eutrophication, aquatic invasive species, new chemicals, and of course, climate change, which is an ongoing concern. But we won't start from scratch. There are early warning systems already embedded in the Great Lakes and elsewhere, but these are not systematically used, and what we hope is to derive a lessons learned approach from these existing warning systems. So in the course of the early warning system framework development, in phase 1, we created a structure, or we created a proposed structure for the glues, which would involve a specific entity embedded within the IJC that would report directly to the Great Lakes Water Quality Board. This would be supported primarily by subject matter experts that are provided by the parties, that is the US and Canada. And the glues, the IJC would ensure that the commissioners are aware of emerging issues through oversight of this early warning system. And the last part of the proposal is, of course, that there needs to be ongoing evaluation of such a system. So when do stressors merit action? You know, how do we pull the plug? How do we raise the flag? In the case of an invasive species or a disease, the first occurrence can be the warning. In other cases, we need to assess the toxicity or ecological thresholds that are being addressed. And this requires that we understand the underlying science that is driving these stressors. So the early warning system framework, which I'm going to describe very, very superficially, because it literally is still in draft form and will be considered by the work group a week from today, actually, has 3 different components. Many of these components have already been described by my colleagues. But in the case of the early warning system for the Great Lakes, we're proposing a system of systems. That is, for each unique stressor, we would have an early warning system that is unique for that, but we would have a catalog of early warning systems that would be linked, and we would have this early warning system body that would be overseeing the interactions across all of these different stressors in order to address both known, unknown, and suspected stressors. So this would require diverse data input coming from multiple data sources. There would be multiple decision points along the way. This would be embedded in an adaptive management framework, and hopefully the structure of this framework meets the needs of the Great Lakes Water Quality Agreement. In phase 1, a critical component is pulling in all of these data, identifying, screening, and basically building an inventory in which we would classify stressors into categories of like things so that we can use similar data, similar analytics and protocols for identifying the risk and importance of those values, of those stressors. The outcome of phase 1 would be a classified list of potential stressors, that is a library. We would be looking for data anomalies that could be used to screen particularly for unknown stressors and threats. And through this process, we would have an initial assessment of the importance and also whether they're actionable or not. Many threats are just not actionable, and so you don't want to waste money and resources on those. At the end of the day, the actions would be to promote or demote stressors. They're either important or actionable or not. We would report those priority threats to the Water Quality Board, and then go to the next step in which we would design the actual early warning system for that particular stress. The outcome of phase 2 would be to develop a threat-specific team of experts to document the science, the indicators, the thresholds, the data streams necessary, that kind of thing. Identify the action threshold, evaluate the risk, and respond, identify potential responses. The actions would be, again, to demote or promote that stressor and to pass information on to the Water Quality Board for those primary priority stressors. Lastly, we would implement and operate this. The outcome of this third phase would be a library of early warning systems, which as I mentioned, would be overseen by this core team of individuals within the early warning system group. Each of these would be specific to individual stressors. There'd be an action plan for responses, and the actions, of course, at the end of this process would be a notification to the Water Quality Board of specific threats and information that would be passed to the parties in order to respond to those threats. So the parties are in charge of responding to threats. The IJC is just the source of information. So the workflow that's involved in this process has been described by John and Dave, but this is just one example in the different classes of threats where the early warning system group would be scanning many different data. We would specify the types of data, the frequency, the scale and resolution needed. We would identify the action thresholds for individual stressors, such as nutrient criteria or ecological thresholds that we need to be looking for. Ultimately, we would identify who needs to be alerted and who needs to be in charge of responses. So at the end of the day, we know that early warning systems depend on the process of horizon scanning at the core of an early warning system. Without horizon scanning, there just is no early warning system. It'll ultimately result in a library of individual systems with a common mechanism for alerting and responding to threats and stressors. And I think the key takeaway from this entire briefing is that when we think about funding for science and moving forward, we need the funding for science and we need the funding for ongoing monitoring programs because those are basically the underpinnings of horizon scanning and early warning systems. So I'd like to acknowledge the International Joint Commission for funding this activity. And that list of folks are the folks that participated in our last work group meeting. So they're a core part of our work group, which also includes a number of other folks at the end of the day. So please let us know if we can answer questions. There's our emails, and Todd, we can.
Yep. Thank you very much. Okay, I think what we want to do is I'm going to have the speakers stand up here because of the way the cameras are, and we'll just field questions. Folks that are online, please keep your questions coming. And I'll deal with the questions that are in the chat first, and then I'll open it up to folks that are here. So firstly, this is for Jonathan. Does the Fish and Wildlife Service, NIH, or any other agency maintain an operational database of international zoonotic threats?
Good question. We are in the early stage of the project that I described, but I will say the short answer is not that I'm aware of. We're in the process of accumulating and scouring, everywhere that we can for these kinds of data. There are bits and pieces here and there, but we're learning that there really is no one centralized database where these are reported. And for example, you'd be surprised, like simple questions such as, what is the list of zoonotic pathogens that have come into the United States through the wildlife trade? It seems to me like a simple question, and it's an important question. And there really isn't a database that has that information at the moment. And that's part of what we're trying to create. And that's what we're learning through horizon scanning, is that, not to assume these things are there that seem like they should, seem like, oh, it's why wouldn't we? Well, it just hasn't come to the forefront yet because we haven't had these discussions and looked at these new issues. So yeah, it brings up a lot of uncertainties.
Yeah, and then we're going to make it more generalizable. So David and Lucinda, you guys are pulling all of these data sets together. Are you creating data products, data repositories for everything you know about the Forest Service, for everything you know about the Great Lakes? So you're going to all this effort of finding these data, putting them all together, and then are you creating sort of a holistic data product that the next time we look at these data, we already start there? I'll start with you, David.
That would be a great project, and we need to do that. What we're doing instead is, like I mentioned, this top 10 emerging issues project right now. Rather than give someone access, anyone can have access to our database of horizon scanning hits, but it doesn't mean much to look through thousands of individual scan hits. And so the analysis is what maybe is more useful than the big database for horizon scanning. And because we're in research, it's publish or perish. We publish everything we do, and so this top 10 emerging issues will be published early in 2023.
Great Lakes.
So it's an interesting and actually not terribly straightforward answer. Because the Great Lakes is a transboundary binational resource, data are not always available that are seamless across the entire basin. So there are tons of data available, and there are monitoring systems such as Great Lakes Observing System, which compile ongoing data in real time. The question of whether there is a central library that has all of the relevant data, the answer to that is no, and it's one of my career goals.
Well, this is a perfect segue to another question. Do the speakers see a need for a cross-agency coordinating body for horizon scanning related to ecological threats, similar to the Department of Homeland Security for human threats?
I think that would be an amazing thing. And I think to a certain extent, this early warning system framework for the Great Lakes could be the underpinnings of such an agency. And given that the International Joint Commission and the Great Lakes Water Quality Agreement has a formalized process for managing the system, that would be a great place to start. That.
Jonathan, David, anything to add?
Yeah, I would strongly agree. I think that in the realm of what I'm working on with wildlife and public health, that it's, as I mentioned earlier, it's easy for government agencies to get really focused in what they do and their priorities and their funding, and they do what they do well with what they have. But the emerging issue is that there are always gaps. There's gaps between different missions of different agencies. And there's also a lot of misperceptions, both in the public and backwards and forwards, about who's doing what. And I think until there is a centralized, mode of communication and collaboration, that's what's really going to show us, how to fill these gaps and be more efficient with what our goals are and how to achieve them.
Great. David, anything to add?
What they said.
Okay. Well, we'll stand up here because you don't get off the hook that easily. How is the U.S. Forest Service considering the rights of nature movement with respect to strategic planning of forest management in the future?
That's one of our emerging issues, the rights of nature, and it's changed. It's been an issue that's been around for a long time, so it's not a brand new issue, but it may be accelerating. And so we haven't done any real in-depth analysis of that, but we're paying attention to it and regularly post scanning hits related to that.
I don't know if we'll know the answer to this, maybe somebody in the audience here. Which House Appropriations Subcommittee would be best to track this process? No idea. Yeah, okay. Any staffer? No, anybody have any ideas?
Probably the Commerce, Justice and Science.
Oh, the suggestion is Commerce, Justice and Science. Okay, great. This question that actually comes from me. Anytime you tackle a socioeconomic issue, like all of you are, data interoperability seems to always be the biggest limitation. Now we have what seems to almost be ubiquitous AI, machine learning approaches. How is artificial intelligence being used, and is it helping to pull together this sort of conglomeration of data that are in all kinds of forms? And whoever wants to step in.
I'll start because the whole issue of how you detect an unknown threat necessarily is going to be dependent on AI and machine learning techniques. So the key feature or the key process in detecting an unknown threat is to take in a lot of data and look for anomalies. The only way you can do that is big data.
Yeah. Anybody else? Step in?
Yes, so a slightly different take on that is in horizon scanning, there are many different approaches. And so in our approach, we have human scanners. We have a team of horizon scanners who search a wide range of information sources for signals of change. There are also a number of AI-based horizon scanning systems, and we're looking into those. We'd like to have the budget to do that. But I was talking with Professor Andy Hines at the University of Houston recently, who wrote a short paper about AI and horizon scanning. And he feels that we're not quite there yet. These systems are getting better, but it's very difficult to identify signals of change. And so in some ways, trained human scanners can still do it better than the AI, but I think that's going to change in 5 years or less.
I bring it up. We have a scientist at Florida International University who takes water quality samples, and he prides himself on creating a library of unknown unknowns, because they might be an emerging contaminant in the future. But the amount of computing power for just water contaminants is amazing. And now you guys are talking about looking at chats, looking at social media, and then all the physical, biophysical data. I mean, I just can't even imagine the amount of data you're dealing with. All right, thank you very much. Anybody in the audience, any questions? Yeah, Bill.
Wondering if you might reflect on the potential role of I'm going to call it DARPA T, or DARPA threat. One of the more interesting operations, sort of forward-looking, outside-the-box thinking is something DARPA, whatever, we're developing military applications, but then there's the DARPA E for energy development. And it would seem that a more concerted effort is to identify these threats, not just within a homeland security, it's sort of a narrow focus. Could be an interesting way to go. And I was wondering if you might reflect on that or other ideas.
So just to paraphrase in case you couldn't hear, what's the role of DARPA as a sort of an overarching agency to?
This model.
Oh, as a model for assessing future threats.
I'll just comment briefly. I mean, DARPA has been so successful in what it does, and over the many years, and that type of model would be I think a tremendous approach for this kind of problem, identifying both ecological threats and opportunities as well. And that's a great idea.
Anybody else? All right, maybe the last question, is the rights of nature movement a threat or an opportunity? That's kind of a loaded question. Yes.
Yes, yeah, both, I guess. Yeah, it's one of those cultural changes, change in people's values that are the ones that oftentimes can really be, can really have big transformative effects in the way that we manage natural resources and the environment and ecological systems. But yeah, so.
All right, very good. Join me in thanking our speakers. On behalf of AERC and AIBS, we thank you for attending. I want to personally extend a thank you to Jocelyn Pandey and her whole team at AIBS. They're sort of the brains of organizing and running these kinds of events. So we thank you very much for your collaboration on this, and have a great day. Thank you.
Thanks, Todd.